Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about a small sample test, that is in particular mean test, that is called a student's t-test. In student's t-test, we have seen a t-test for single mean and t-test for difference of means. In continuance with that, in this session, we will be studying some problems in small sample test, which is t-test for difference of means and for paired observations. Interval estimation is also done in this regard. Sample of sales in similar shops in towns A and B regarding a new product yielding following information. For town A, x1 bar is equal to 3.45, summation x1 where I is equal to 1 to n ranges, x1 is equal to 38 and summation x1 square is equal to 228, n1 is equal to 11, and for the same shop in town B, x2 bar is equal to 4.44 and summation x2 is 40, and then summation x2 square is equal to 222, n2 is equal to 9. Is there any evidence of difference in the sales in two towns? Test at 5% level. Now, this problem is slightly different from the previous ones because here you are not given the summation x1 minus x1 bar, whereas you are given only the summation x1 square etc. From that we have to find out S1 and S2, so that we find out S and then we compute the calculated value of t. Now, first of all, the identification is in both the samples the size is 11 and 9, therefore it is a small sample, and moreover two types of samples are given, one from town A and another from town B, therefore difference of means has to be adopted, and then a t-test for difference of mean is the appropriate test here to be applied. So, the solution is first of all we set up H naught. H naught is mu 1 is equal to mu 2. There is no difference. What is the question? Is there any evidence of difference in sales in two towns? So, according to H naught, there is no evidence of difference of sales in two towns A and B. Then step 2, H1 says that mu 1 is not equal to mu 2. So, there is evidence of difference of sales in two towns, that has to be repeated. Then step 3 says level of significance is 5% and degrees of freedom is equal to n1 plus n2 minus 2, which is equal to 11 plus 9 minus 2, which is equal to 18. Then step 4 is the calculation part. T is equal to x1 bar minus x2 bar by s into root of 1 by n1 plus 1 by n2, where s is equal to root of summation x1 minus x1 bar whole square plus summation x2 minus x2 bar whole square by n1 plus n2 minus 2. Okay. In this question, even x1 bar x2 bar is given, but summation x1 minus x1 bar whole square is not given, therefore that we have to find out. Okay, this x1 bar x2 bar is given, only thing summation x1 minus x1 bar whole square is not given, whereas the different values are given. We have to compute this using the values given in the question. Okay, what is that? This is equal to summation using a minus b whole square x1 square plus x1 bar whole square minus 2 x1 into x1 bar. Okay. After simplification, this goes as summation x1 square plus n into x1 bar whole square minus 2 x1 bar into summation x1. So, summation x1 square is 228 plus n is 11 and then some x1 bar is 3.45 square minus 2 into 3.45 into summation x1 is 38. Okay. And this value after simplification it comes to be equal to 96.728. Okay. Similarly, summation x2 minus x2 bar whole square is found out as a summation x2 square plus n into x2 bar square minus 2 x2 bar into summation x2. Now, substituting all the values, 222 plus 9 into 4.44 square minus 2 into 4.44 into 40. Okay. This value comes to be equal to 44.224. Okay. Now, substitute all these values in S. Therefore, S is equal to 96.728 plus 44.2224 divided by n1 is 11 plus 9 minus 2. This is equal to 2.79. So, S is equal to 2.79. Therefore, now T is equal to x1 bar minus x2 bar by S into root of 1 by n1 plus 1 by n2. Substitute x1 bar value. X1 bar value is 3.45 minus 4.44 by S we have just now found out 2.79 into root of 1 by 11 plus 1 by 9, which is equal to this value is 0.789. Therefore, calculated T at 5% comma 18 degrees of freedom is equal to, we just found out as minus 0.78. So, within modulus if you put this is 0.789. We are in actually step 5 conclusion step. So, tabulated T at 5% comma 18 degrees of freedom. If this you have to refer from the tables, 18 degrees of freedom at 5%, this particular value 2.10. So, this is 2.10. Calculated value is much lesser than tabulated value, therefore, H naught is accepted. Since a calculated value is less than tabulated value, H naught is accepted. H naught is accepted in the sense the question there is no evidence. This is your conclusion. There is no evidence of difference in sales in two towns. Next example is below are given the gains in weights of cows fed onto diets X and Y. The gain in weights in pounds are diet X is 25, 32, 30, 32, 24, 14 and 32. Diet Y is 24, 34, 22, 30, 42, 31, 40, 30, 32, 35. Now, the exact question is test at 5% level whether the two diets differ as regards their effect on mean increase in weight. Table value of T for 15 degrees of freedom at 5% is 2.31. Again, the basic identification is you have to use the T test for difference of means, because two types of samples are given. One is a sample of cows fed with diet X and another is a sample of the cows fed with diet Y. Okay. And then you are asked to verify whether the diets increase their effect, whether the diets increase with respect to their effect on the cows. Since it is a difference of means, we have to use a student's T test for difference of means as regards with respect to small sample. And then now we shall start with the step 1, the solution. Step 1, H naught is mu 1 is equal to mu 2. Mu 1 is equal to mu 2 implies the increase in weight of the cow fed with the effect of a diet is same with the effect of diet Y on cows. Okay. So, same in the sense there is no difference. There is no difference in their effect. There is no difference as regards their effect in the sense diet X and Y effect on mean increase in weight. Okay. And step 2 is H1 mu 1. Again mu 1 is not equal to mu 2 because both diet increases the weight. So, we cannot exactly say diet X increases the weight than X, than it is not a comparison. It is not the comparison between X and Y. It is generally diet X and diet Y both increases the weight of the cow. So, there is no kind of comparison between diet X increases or diet Y increases. Therefore, mu 1 is not equal to mu 2 is the appropriate alternative hypothesis, and moreover it is a two-tailed test. There is difference in effect on mean increase in weight. Okay. Next step 3 is level of significance is 5% and degrees of freedom is n1 plus n2 minus 2. How many values are there in n1? Just count n1 1 2 3 4 5 6 7 values, whereas n2 is 10. And moreover it is very important n1 need not be equal to n2 because only 7 cows are taken for feeding with diet X, whereas 10 cows are taken into account for feeding with diet Y. It is not necessary n1 should be equal to n2. Okay. Therefore, n1 is 7 and n2 is 10. So, n1 plus n2 minus 2 gives you 7 plus 2 is equal to 15 degrees of freedom. Step 4, we just now calculate x1 bar, x2 bar, s1, s2 everything and then s, so that we calculate the t value. Okay. So, the t formula is t is equal to x1 bar minus x2 bar divided by s into root of 1 by n1 plus 1 by n2, where x1 bar is equal to summation x1 by n1 and x2 bar is equal to summation x2 by n2 and s is equal to root of summation x1 minus x1 bar whole square plus summation x2 minus x2 bar whole square by n1 plus n2 minus 2. Now, we have this tabular column. This value is x1 and this is x1 minus x1 bar and this is x1 minus x1 bar whole square. This is x2. All these are already calculated, but while doing the problem you have to calculate it. x2 minus x2 bar, then x2 minus x2 bar whole square. So, x1 values are 25, 32, 30, 32, 25, 24, 14, 32. And what is summation x1? Summation x1 values is 189. Therefore, x1 bar will be 189 divided by 7, which is equal to 27. Okay. So, x1 minus x1 bar will be x1 minus 27. Okay. So, each value is subtracted with 27. This minus 2 is 25 minus 27, 32 minus 27, 30 minus 27, like that this particular column is formed. And then its square values, 2 square, 5 square is 25, 3 square is 9, like that this tabular column is formed. Then we have x2 values written. There are 10 values 24, 34, 22, 30 etc. up to 35. What is x2 summation x2? Summation x2 comes to be equal to 320. Then just substitute in x2 bar. Summation x2 will be summation x2 bar will be summation x2 by n2, which is 320 by 10, which is equal to 32. Okay. Then x2 minus x2 bar will be x2 minus 32. Each value is subtracted with 32. So 24 minus 32 is minus 8, 34 minus 32 is 2, 22 minus 32 is minus 10. Like that, this column is formed. Okay. And then its square values are 8 squares 64, 2 square is 4, and then like that this tabular column is formed. So the summation will be, its summation will be summation x2 minus x2 bar whole square is equal to 350. Similarly, this summation x1 minus x1 bar whole square is equal to 266. Now substitute all these values in S. Therefore, S is equal to root of 266 plus 350 divided by 7 plus 10 minus 2, which is equal to 6.4083. This is your S value. Substitute in T. Therefore, T is equal to x1 bar. x1 bar is 27 minus 32 by 6.4083 into root of 1 by 7 plus 1 by 10. Okay. And this value happens to be minus 1.5832. Now, therefore, calculated T is minus 1.5832. Now, we have come to the comparison and conclusion step. Therefore, calculated T at 5% comma degrees of freedom is 15 is equal to modulus of minus 1.5832 is equal to 1.5832. Similarly, tabulated T at 5% comma 15 degrees of freedom is given in the question itself as 2.131. Even if you want to, you can verify it with the tables. For 15 degrees of freedom, 5% is 2.131. So, this is equal to 2.131. Now, since calculated value is less than tabulated value, H naught is accepted. Calculated value is less than tabulated value, H naught is accepted. H naught is accepted in the sense there is no difference in mean increase of diets. This is the conclusion. There is no difference as regards their effect, the effect of diet X and Y in mean increase of weight of the cows. Okay. Next, after discussing the testing for a single mean and testing for difference of means, next we shall discuss the interval estimation in this regards. That is interval estimation in the case of single mean and interval estimation in the case of difference of means. So, what does it say? That is a random sample of size 10. Here you need not set up H naught, H1 etc. Directly we shall identify the corresponding statistic and then apply the formula to find out the interval estimation. Now, 95% confidence interval is required. Therefore, n is equal to 10 and this is a single mean t test. Therefore, the formula is t is equal to x bar minus mu by s divided by root of n, and this is the tabular column regarding this is x, this is x minus x bar and this is x minus x bar whole square. What is x bar? Our summation x is 674. summation x value is 674, so that where x bar will be equal to summation x by n, which is 674 by 10 is equal to 67.4. So, here each value is subtracted with 67.4, which is minus 3.4 and 4.6 etc. These are the squares, x minus x bar whole square, 3.4 whole square, 4.6 square, like that this column has been formed, and this is particularly this column total is x minus x bar whole square total is equal to 108.4. So, now we will calculate the 95% confidence interval for the population mean. So, t is equal to x bar minus mu divided by root n, where s is equal to root of x minus x bar whole square by n minus 1. So, summation x minus x bar whole square we just found out as 108.4 by 9, which is equal to 3.4705. This is s value, and therefore, to find 95% confidence interval, alpha is 5%, therefore, t is taken at 5% and degrees of freedom is n minus 1, n is 10 here, therefore, 9. This is equal to our x bar value is 67.4, mu only we are finding, that has to be kept fixed as it is, divided by s is 3.4705 divided by root of 10. So, just cross multiplying with this we have the tablet. Before that t at 5% comma 9 degrees of freedom is 2.262 from the tables. This is from tables is equal to x bar is 67.4 minus mu divided by 3.471 by root 10. Just cross multiplying 2.262 into 3.471 by root 10. Here you are having plus or minus because of the modulus, which is 67.4 minus mu. Therefore, mu is equal to 67.4 plus or minus 2.4828. Okay. Adding you will have one value and subtracting you will have another value. So, the values are 64.917 and 69.8828. Okay. Therefore, 95% confidence interval means it should be written in brackets. Limits means you can just write out without brackets also. 95% confidence interval is 64.917 comma 69.883. Okay. So, it means your population value lies between 64.917 and 69.883 at 5% level of significance. After discussing the small sample t test for difference of means, in this session some problems have been worked out in small sample t test for difference of means as one-tailed and two-tailed test. Interval estimation also is done in this regard. Based on the discussion, the following question is expected. Can we conclude that two sample data given below suggest that they belong to the same normal population? Apply the test for mean. Sample is given as 1 and 2, size is n1 is equal to 10, n2 is equal to 12, mean is x1 bar is 12, x2 bar is 15. Instead of giving directly the s1 value and s2 values, you are given sum of squares of deviations from mean, that is it means x1 minus x1 bar whole square is equal to 120. Similarly, x2 minus sum of summation x2 minus x2 bar whole square is equal to 314. So, you have to apply the t test for difference of means in solving this problem and arrive at the conclusion whether they belong to the same normal population or not. Thank you.